Hello everybody. What we're going to be doing is lesson 2.2a and we're going to do dilations and proportionality. So in this lesson, please follow along with me. Make sure you guys have your notes out, you're taking them, and you'll have plenty of time to upload them before the end of the class. Okay? So when an object, so let's begin. Make sure you have your notes out. Feel free to always pause it, rewind it, all of that fun stuff. So it says when an object such as a line is moved in a space, it's called a transformation. So basically, if you ever have a shape and you're moving it, you're making it bigger, you're making it smaller, you're moving it up, you're moving it down, that's it's called a transformation. A special type of transformation is called a dilation. A dilation is a shape that is the same but has a different size. A dilation transforms an object in a space from the center of dilation, usually the origin, by a scale factor called r. So what that's just saying is you have a shape and you're going to make it grow or you're going to make it shrink by a scale factor, okay? The scale factor can be represented by the quotient, the image divided by the pre-image. The dilation moves every point of the object so that the point is r times away from the center of dilation as it was originally. This means that an object is enlarged or shrunk. For example, if you dilate the set of points from 0, 0, 3, 0, and 3, 4 by a scale factor of 2, the center of dilation is the origin, and the distance from each point will be 2 times as far as the factor. Guys, all that is saying is I'm doubling the size of the shape. So let's go ahead and actually look at a visualization what a dilation is, okay? So if I have this shape, and I said that's a beautiful shape, now what I'm going to do is have a scale factor by 2. I am going to grow it. So do you see this rectangle? It is growing proportionally each side. All right, so originally what it's saying, if this side length is 3, this side length is 6, and I'm going to do a scale factor of 2, that means I'm going to multiply, I'm going to double both sides by 2. So where this used to be 3, it is now a side length of 6, and where this down here was 6, it is now double to get 12. That's what a scale factor is. It just grows or shrinks. So let me go ahead and erase this so we can jump back here, clear things up just a little bit, okay? All right. So it says graph the connected ordered pairs of 0, 0, 3, 0, and 3, 4 in the coordinate plane. All right, so here's the coordinate plane. As a reminder, when you have one of these, this is 0, 0, it always goes x, y. Now, really quickly, the x value tells you how much you go left and right, and your y tells you how much you go up and down. Then you put the point down on that one value, okay? So let's go ahead and look at this. My first value is 0, 0. So I'm going to put a point there on 0, 0. And then I'm going to go over to 3, 0, which means I'm going to go over, remember it's 3, 0, so I'm going to the right 3 spots and then up 0. So I'm going to go up over 1, 2, 3 and put a dot right there because it told me to go over 0. Now my last one right here is 3, 4. This tells me to go to the right 3 and then up 4 and then put a dot. So you always start at the origin. I'm going to go over 1, 2, 3, and then up 1, 2, 3, 4, then put a dot. Sometimes kids want to put a dot here and a dot here. No. You go over 3, up 4, put a dot. Okay. Next thing is I want to connect all of these dots. So I'm going to do that in pink. So we start at the origin, and we're just making a little triangle right here. Up, up, and then down right here. That is what is called my pre-image, okay? What a pre-image is, it's your original shape. That's all it is, original shape. Original shape. Now, whatever we do, if we grow it or shrink it, that's going to be called my pre-image, okay? So it says dilate each ordered pair by a scale factor of 2, okay? It means I'm going to multiply each side by 2. Of dilation from the origin. Plot and connect the new ordered pair in the different color on the coordinate plane. This new object is called the image. So remember, original shape, pre-image, new shape's going to be called the image. You can label these as A, see these little apostrophes, so A apostrophe, B apostrophe, C apostrophe, those are called prime. So A prime, B prime, C prime. All that means is it's comparing our old shape from the new shape. So for instance, what I mean by that, if this is A, this is B, this is C, when I plot these new points, we're going to see what this looks like. Now it says grow it by a scale factor of 2. Well, let's look at this. And we're going to start here. I'm going to grow this image out by 2. So this length is 1, 2, 3, right? Well, 3 times 2, if I double the length, would give me 6. So that means my new point would be 6, 0. All right, perfect. And now over here, my height was 1, 2, 3, 4. Remember, that point was 3, 4. If I doubled both of those, if I doubled 3, that would give me 6. If I doubled 4, that would give me 8. So that would give me then my new ordered pair, which was 6, 8, all the way up here. Okay, so now I'm going to connect these points starting at the origin of 0, 0. So let's go ahead and do that. So I'm going to take this image, start right here, grab my blue marker. We're going to go from here to here, here to here, and here to here. So you can see that is a scale factor of 2. I doubled it by 2. Now remember, in pink, my triangle ABC was my original, so we call it the pre-image. And it also wanted us to label these values for the blue one. So this would be my A prime, B prime. See how this is B and I grew it to become B prime? This is C, I stretched it out to become C prime. That's how you know those little apostrophes, those little prime symbols. That's how you know it is the pre-image and not the image. So this would be the pre-image, because that spells image. I originally started with the pink and then grew it out. So now let's look at the length. The length of A prime, B prime, A prime, B prime is 6. I started at 0, I went over 1, 2, 3, 4, 5, 6. And the length of, I'll do this in pink, of AB is just 1, 2, 3. That simplifies to 2. So that's the scale factor. Now if we look at B prime, C prime, that is in blue. I started down here and I went up 1, 2, 3, 4, 5, 6, 7, 8 spots. And over here on the pink one, I just go up 1, 2, 3, 4. And the scale factor there is 2. So that's how you could double check the scale factor. It's just you take the side length and divide it by side length of your prime, and you divide it by your image. Okay, or excuse me, you take your new image of a side length, and you divide it by the pre-image. So now what we're going to do is look at a different one. So if I'm going to do this we'll do it in light green. If I wanted the scale factor to be cut in half, so instead of making it bigger by 2, I'm going to shrink it by 2. I'm going to cut it in half. So if this length is 1, 2, 3, half of that would be 1.5. Now over here, it's 1, 2, 3, 4. So my length is 4. Half of that is 2. So I would just go up then 1, 2. This would be my B. I already have my B for my image, pre-image. I already have B prime. Well, now I'm going to put 2 apostrophes for B double prime, okay? Which means if this is C, all the way up here was C prime. This would be C double prime. Now, some students say, well, how do I know which one's prime and how do I know which one's double prime? It doesn't matter. The only one, it just goes in order. So your pre-image is always the first. Whatever you either dilate it by making it bigger or smaller would be your prime. And if you, then the second one would just be double prime. So if I would have done this cutting it in half first, this would have been actually prime and not double prime. So it all just depends on the order. So I want you to see I shrunk it. Now if I looked at this, it says complete this. So it says A double prime and B double prime. So this would be A, B double prime. So it'd be 1.5. That's what my length is over AB, which is 2. That simplifies to 0.75. And if I looked at this, oops, I messed up right there. Sorry. I didn't divide by 2. So one more time, this part was correct. AB prime was 1.5 and AB was 3. And that would simplify to 1/2. That's exactly what it said up here. Same idea now. I had BC, which was 1, 2. I went up 2 units. While originally, if we look at the pink, I went up 1, 2, 3, 4. And that would also reduce to 1/2, also matching my scale factor 1/2. So how do the line segments in the pre-image compare to the line segments of ABC and ABC prime? Well, we have basically 2 answers here. So the pre-image is, so my original, it's half the size of A prime, B prime, C prime. So if you looked at that, it's half of that. So this is the original. So how does this side compare to this side? Well, it's half of it. Okay. And then I'll switch colors. And it is double the size of A double prime, B double prime, C double prime. Okay, so it's so it's half the bigger size and it's double the smaller one. Okay, so a dilation produces an image that has the corresponding parts that are blank to the pre-image. Okay, that are proportional to the pre-image. The pre-image and the image are similar figures. Okay, similar figures have corresponding angles that are the same. So angles are the same, and corresponding angles, corresponding sides that are proportionally related as again. So right here, do you guys see this squiggly sign? This squiggly sign right here, it means similar. Objects are similar. You can write this down. Objects are similar if they have the same, if angles are the same, and sides have same ratio. Okay, so it says write a similarity statement to the trapezoid. So let's go ahead now and look at this. I started off with this big trapezoid. You can tell because it doesn't have the prime. So this is A prime. Remember, this would be the pre-image, and this is the image. So I shrunk it. And remember, they are proportionally related. So it says these are similar. So we would say that trapezoid A, B, C, D is similar to A prime, B prime, C prime, D prime, okay? So let's complete this statement, guys. Measurement of angle C, well, what is that going to be similar to? You just write the corresponding angle. It will be similar to the measurement of angle C prime. I'm not sure if you learned this in 7th grade. This just stands for the measurement of angle C is similar to the measurement of angle C prime. Now it says if the measurement of angle A is 90 degrees, well, what must the measurement of angle A prime be? Well, angles are the same for corresponding angles and sides, so this would also be 90 degrees. Now let's go ahead and write this proportion. So it says AD. What is AD? AD is 1, 2, and this right here, AD is 1, 2, 3, 4, 5, 6, 7, 8. So my original side was 8. I shrunk it down to 2. And if I reduce this, this would be 1/4. That means that the scale factor is 1/4. Okay? And you can compare that with all the sides. And we would see that it's the same length. So if you look at this, this is 1, 2. This right here would be 1, 2, 3, 4, 5, 6, 7, 8. Oh, look at that. That's 2 over 8, which reduces to 1/4 as well. And that would work for all of the sides. So if you look at this, this is 1, 2, 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that reduces to 1/4 as well. Now, I'm going to ask you, are the two sides congruent? So how do I do this? So what we're going to do, guys, is what we need to do is compare all of the side lengths. So what do I mean by that? Well, what is my shortest side on the big shape? That's right here. What is my shortest side here? It's 1/4. All right, let's get a new highlighter color. What's my medium size? Oh, that's right here. What's my medium size? That's right here. Nope, that's not right there. That is right here. And then last but not least, I'm just going to do red. This is the largest side. This is the largest side. So what we're always doing, remember, we're comparing basically we're trying to find the scale factor. So basically, if you remember the ratio, it's always the image over the pre-image. And it doesn't matter. So what you need to do is make sure that all three of these sides are proportionally related. So how do I do that? Well, I'm just going to look at the ratio of 2 over 1.4. Is that equal to, so I just did 2 over 1.4, the small side over the small side. Is that ratio equivalent to, okay, let's do purple, 4 over, so I did this 4 over the smaller side purple, 2.8. And is that equal, then I'm going to go ahead and do this, 5, so the larger red side over the smaller blue side, 3.5. Each and every one of those ratios needs to be equivalent. So if I went ahead and did this on a calculator, let's see what that would look like. Okay, so let me bring up my calculator. We're just going to bring up a little web browser here. So if I did 2 divided by 1.4, that would give me 1.42. Okay, so we got 1.42. Actually, you know what? What we can do, I don't like using calculators, you know me. If I multiply all these by 10, this would give me 20 over 14. This would give me 40 over 28, and this would give me 50 over 35. Now let's reduce all these fractions and see what I get. If I reduce these both by 2, this would give me 10 over 7. Okay, that's it reduced. If I reduced all these by 5, let's see, 10, 20. This would be 2 point. Sorry, I messed up. This was 2.8, so this would be 40 over 28. If I reduced all these by 4, 40 divided by 4 is 10. 28 divided by 4 is 7. Oh, look, those ratios are equal. And if I divided all these by 5, 50 divided by 5 is 10. 35 divided by 10 is 7. Look at that. When I looked at the ratios, each and every one of these were equal. Therefore, you would say that these two shapes are proportional, or excuse me, are similar. So are the two figures similar? We would say yes, because their ratios are equal. Boom. Perfect. So now let's go ahead and look at these. So just by looking at these, you're like, they don't look super similar. So we need to prove it mathematically though. So we need to match the corresponding sides. So if I look at this with my highlighter, I notice this is my top side. This is my top side. This is my base. Oops. This is my base. And this is my base. So when I do this, let's go ahead now and compare. So this would be, let's go ahead and just say this is my image and this is my pre-image. And when I do this, it's 1, 2, 3, 4. So I have 4 over 1, 2. Okay, that reduces to 2. Now this ratio here needs to reduce to 2 as well. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this needs to be 4. So we go 1, 2, 3, 4, 5, 6. When I reduce this, I'm going to get 4 over 3. do those reduced ratios equal each other? And we would say, no, this is not similar because they do not have the same scale factor. They do not have the same scale factor. Okay. All right, so let's go ahead. We have just a handful of more questions here. Now, I am going to figure out what a missing side is. What we're telling you now, guys, is this does have a same scale factor. Some of you might be able to identify what the scale factor is just by looking at it, and others of us might need a little bit more extra time. So let's go ahead and look at this together. When I see this, I have, let's match the side. So here's my right angle, so I'm going to match this side coming up here with this side coming down here. Why did that do that? Let's erase this. All right, well, that blue line is just going to be there. And I am going to match this red line with this red line right here. Okay, now let's go ahead and write a ratio here. Remember, it's always the pre-image over the image, or vice versa. What do they have for us? The image over the pre-image. And it doesn't matter which one is which, because it doesn't tell us. So basically what I'm going to have is, well, this side was big. I'm going to have that on X. And then over the corresponding blue side, which is 6. So I have the big blue over small blue. And I'm going to set that equal to corresponding sides. Now, they're trying to trick you. You see how this is an 8 and this is kind of empty? So we can't really do anything there. So what we're going to do then is have 25 over 10. So how did I get the 25 over 10? So let's review this. I'm going to match big blue with small blue. All right, so I got the big blue over the small blue. I'm going to set that equal to my reds now. Big red over small red. So remember, big, small, big, small. Big blue over small blue equals big red over small red. You got to match corresponding sides. As a reminder, corresponding sides are just matching side lengths there, okay? So now let us go ahead and look at this part. Whenever you have a ratio proportion, the way you solve it is just by cross multiplying and dividing. So you'd multiply it like this. You would have 10x is equal to 6 times 25, which is 150. And what we're going to do there is just divide both sides by 10. This will give me x equals 15. So my missing side length right here is 15. All right. So we're going to look at the next one.